Hey, welcome to The Explainer. Today, we're going to talk about something pretty epic, the constant battle between land and sea. We're breaking down the powerful forces that shape our coastlines and looking at how on Earth we try to manage them.
So how exactly does the ocean turn solid rock into the beaches and cliffs we see every day? Well, to get to the bottom of that, we first have to understand the engine driving all this change, the waves themselves. It all seems simple, but the physics here is literally what carves out the world we know.
It's kind of funny, but to understand how coasts get built up, we first need to look at how they get torn down. So let's start with the villain of our story, if you will, the incredible, destructive power of the sea.
So where do these waves come from? It all starts with the wind. As it blows over the ocean's surface, that friction basically grabs the water and creates a swell. But here's the thing, not all waves are the same. Not by a long shot. They basically fall into two main camps.
And this is the key difference, right? It all comes down to one thing. Is the wave dropping stuff off, or is it taking it away? Constructive waves, well, the name says it all. The swash, that's the water rushing up the beach, is stronger, so it builds the beach up. But with destructive waves, it's the opposite. The backwash, the water dragging everything back out to sea, is way more powerful. And for this explainer, these destructive waves are what we're really going to focus on.
Okay, so these destructive waves are the architects of erosion. And they've got two main weapons in their arsenal. Now listen up, because if you've got an exam coming up, you absolutely need to know these terms. Seriously, write these down.
First up, we've got hydraulic action. Just think of this as pure brute force. A wave smashes into a cliff, and it's not just water. It's forcing a huge amount of air into every tiny crack and fault line. That pressure builds up, it expands, and then, bam, it basically blasts the rock apart from the inside. It's like a giant sledgehammer hitting the cliff over and over and over again.
The second weapon is abrasion. Now this is where it gets interesting. The wave isn't just hitting the cliff with water anymore. It's armed. It's picked up ammunition, sand, pebbles, even big old rocks, and it just hurls them at the coastline. This acts just like sandpaper, grinding and scraping and wearing away the cliff year after year.
All right, so we've got our weapons, right? Hydraulic action and abrasion. Now let's see what happens when you unleash them on a solid piece of land, a headland, for, thousands and thousands of years.
And this is such a cool process. It all starts with something tiny, just a little weakness or a crack in the rock. Hydraulic action gets in there and pries it open, digging out a cave. But the sea doesn't stop. It keeps battering away, sometimes from both sides of the headland, until it punches right through, creating this incredible natural arch. But the story's not over. The top of the arch gets weakened by wind and rain, and eventually it collapses, leaving behind this lonely pillar of rock standing out in the sea. That's what we call a stack. And finally, even that stack gets worn down at the bottom by the waves until it too gives way, leaving just a little stump that you might only see when the tide is out. From a massive headland to a tiny stump. Pretty amazing, right?
So you've got this constant, relentless attack on our coasts. What do we do about it? How do we protect our towns and roads that are sitting right on the edge? Well, that brings us to the whole field of coastal management. When it comes to managing the coast, there are basically two main schools of thought. On one hand, you've got what's called hard engineering. This is the fight fire with fire approach, building big, man-made structures like seawalls to just stop the waves in their tracks. Then you've got soft engineering, which is a bit different. It's all about using more natural methods and trying to work with the sea's processes, not against them.
A classic example of soft engineering is beach nourishment. You'll see this in places like Pevensey Bay. The idea is really simple. You literally just add a ton more sand to the beach. This makes the beach bigger and wider, so it acts like a giant sandy cushion that soaks up the wave energy before it can do any damage to the cliffs behind. It looks natural, it's great for tourism, but here's the catch. A really big storm can come along and just wash it all away. Then you're back to square one, and the long-term costs can really add up.
Now on the hard engineering side, you've got something like groins. These are those wooden or rock fences you see sticking out into the sea. They're pretty clever, actually. They're built to interrupt a process called longshore drift, which is just sand moving sideways along the coast. The groins act like a dam, trapping the sand and building up the beach in one spot. Awesome, right? Well, yes, for that one spot. But here's the huge knock-on effect. By trapping the sand, you're starving the beaches further down the coast, and with no new sand arriving, their cliffs become way more vulnerable to erosion. You solve one problem and create another one.
So what's the big takeaway here? It's that there is no easy, perfect answer.
Every single method has its pros and its cons. Defending one bit of the coast can often make things worse somewhere else, which leaves us with this big final question. In this constant battle with the sea, should we be trying to fight it head-on with bigger, stronger walls, or should we be learning how to work with its incredible power?